Hey everyone, welcome back. We're going to go ahead and finish 10.5 polar coordinates. Today we're going to be converting polar equations to rectangular form. So the essential question is, how do I convert polar equations to rectangular form? Okay? So the whole idea is that we're going to be provided certain polar equations, and our goal is to change them into something that we recognize in rectangular form. So the first one we're going to do is r equals 3. So this right here is a polar equation. I'm going to make note of that because anything involving r or theta is a polar equation. Now, what does this graph exactly look like? If I were to graph this just as is, essentially I'm talking about some object with a radius of 3. So let's assume that this is a length of 3. It ends up going round and around and around and around. Obviously, that's not even, but it creates a circle. So we're talking about a circle with a radius of 3. Okay? We know that from our conic sections that circles have a specific type of equation. So obviously, this is going to have to be connected to that equation in some way. Okay? So the way we're going to do this is actually to square both sides. How do I know that? Because yesterday we learned this one, r squared equals x squared plus y squared. And that's going to be a very useful conversion method. Okay? So I'm going to square both sides. I end up getting r squared equals 3 squared. Okay? I replace r squared with x squared plus y squared, and that's going to be equal to 9. And just like that, that actually is the rectangular form for my polar equation. Okay? So sometimes you just need to remember this equation over here, and that way you get to replace and substitute and find your rectangular form. So now we have the equation of a circle with a radius of 3. Okay? Moving on, we're going to go ahead and do example 2. This one's a little bit different. Rather than being given an r value, we're given a theta. So example 2, theta is equal to pi over 3. So if I were to sketch that one, pi over 3 is 60 degrees, so it's going to be approximately somewhere over here. And essentially what I'm seeing is that it's going to become a straight line. So the equation that should result is a linear equation. So we're going to see how exactly does this turn out with just a theta and some radian value. What I need to think of is tangent. The reason I'm thinking tangent is because tangent brings in the x and y, which I'm going to need for my rectangular form. Okay? So over here we got x and y thanks to the r. Here I'm going to have to use tangent since theta needs to be connected to some trig ratio. We'll use tangent in order to bring us x and y. So I'm going to take the tangent of both sides. I get tangent theta equals tangent of pi over 3. By taking tan of pi over 3, for those of you who don't remember, you may use your unit circle or you may draw a triangle. But tangent of pi over 3, that becomes the square root of 3. Okay? And then tangent theta, I'm going to go and leave it as is for now, because we need to figure out what can I do now. I'm here at tangent theta equals the square root of 3. What could I do? Well, I remember that tan theta is equal to y over x. Okay, so that's going to be really important. So I'm going to go ahead and substitute tan theta with y over x equals square root of 3. Okay, now all I need to do is multiply x to both sides, and I get y equals square root of 3 times x. So this is a linear equation with the slope of the square root of x, so about 1.7. Okay, and that pretty much matches up with this graph that we have right here. Okay, the final one, example 3, incorporates both r and theta. And we have r equals secant of theta. Okay, now here It's a little tricky. Some of you might feel compelled to square both sides and change it to x squared plus y squared, but then that would lead you to having secant squared, and it could possibly lead out to the correct equation in the end, but that's going to take a lot more work. So before we start though, let's go ahead and see what this graph is going to look like. So if you have a graphing calculator, you can always check your answers by graphing polar equations. So here I have 1 over cosine theta, and that's the same thing as secant theta. If I were to graph it, let's see how it looks. So it goes up and then goes up right there. We're going to have a vertical line. So I'm going to be expecting x equals something, and it looks like right here x should be equal to 1. Let's see if that works. Whenever we have something like this, the same method that we used before where we convert to sine or cosine will help a lot. So in this case, secant theta, I'm going to convert that or change that to 1 over cosine theta. Okay? At this point, we want to think back to what we did yesterday, or 2 days ago maybe, and recall that r cosine of theta is equal to x. Okay? How can I get that? I'm going to multiply both sides by cosine of theta. So I do that. I get r cosine of theta. Cosine theta cancels. Now I have r cosine theta equals 1. I replace this with this over here. So x is equal to 1. And there you go. That's my rectangular form for this polar equation. All right?
First,
if you have any questions, feel free to write them down and we will answer them tomorrow. See you guys later.